Let's find the derivative of y equals cosine 3x. For this, we have to use the chain rule. So the first step is to take the derivative of cosine. So a good way to find the derivatives of sine and cosine is to use this chart here. The derivative of cosine will be negative sine. So whenever you want to take a derivative, you would just go clockwise. So the derivative of sine is cosine, derivative of cosine is negative sine, derivative of negative sine is negative cosine, the derivative of negative cosine is sine. And the way to remember this is here is positive sine, and then across from it is negative sine. Here's positive cosine, across from it is negative cosine. Okay. All right, so the derivative of cosine is negative sine. For the chain rule, you always keep the inside the same, and then you want to multiply by the derivative of the inside. So the inside is 3x. The derivative of 3x is 3, so we'll put that in front. Next one, we have y equals sine 5x. So sine, the derivative of sine is cosine. So first take the derivative of sine, which is cosine. Keep the inside the same. And then you want to multiply by the derivative of the inside. Inside being pi x, so the derivative of that is just pi. Next one, we have 3 times tangent 4x. So I can keep the 3, and then the derivative of tangent is secant squared. Okay, so we'll take the derivative of tangent to be secant squared. Keep the inside the same. The inside is 4x. And then you want to take the derivative of 4x, which is 4. So we'll put that in front. We have to multiply 4 with 3 to get 12. And that would be 12 secant squared 4x is our derivative. For 74, this one's a bit tricky. It's good to rewrite this as 2 times tangent of x all cubed. So this is just equivalent. I did not change the value or anything. And this one you have to use the chain rule. So the chain rule, you always start with the outside function. So previously the outside functions were the trig functions. But now the outside function is the cube. So think of this as like x cubed. How do you find the derivative of x cubed? You bring down the power and then subtract 1 in the exponent. But now the chain rule says you have to take the derivative of the inside, and the inside being tangent of x. Okay, so this is what's going to happen. We're going to bring down the power, so we'll have 2 times 3 is 6. Keep the inside the same, and then subtract 1 in the exponent. 3 minus 1 is 2. And now I'll take the derivative of tangent, which is secant squared. So that's basically what we have here, 3x squared. But you have to take the derivative of the x in our case. Moving on, we're given f of x is cosine 3x, and we want to find the derivative at x equals pi over 9. So in order to find the derivative first, you want to take the derivative of the outside, which is cosine. So the derivative of cosine is negative sine. We'll keep the inside the same. And then multiply by the derivative of the inside, which is negative 3. So the derivative of f is negative 3 sine 3x. And now we just need to plug in pi over 9. So that would be negative 3 sine of 3 times pi over 9 is pi over 3. So this will be negative 3 times root 3 over 2. And so the answer is E. Now the next one, f of x is sine of x squared plus pi. We want to find f prime of square root of 2 pi. So let's take the derivative. So again, we have to use a chain rule. Take the derivative first of the outside function, which is sine. Derivative of sine is cosine. Always keep the inside the same. And then you multiply by the derivative of the inside, which is 2x. Now we need to plug in the square root of 2 pi. So you have cosine, square root of 2 pi squared, plus pi times 2 times the square root of 2 pi. Now, the square root of 2 pi squared is just 2 pi. So this thing is 2 pi. Now we want to add it with pi to get 3 pi. So that would be cosine 3 pi times 2 root 2 pi. Cosine 3 pi is negative 1. So this will be negative 2 root 2 pi. And the answer is A. Now let's move on to the next one. We have an equation of a line tangent to the graph of y equals x plus cosine x at the point 0, 1. So let's find the equation of the tangent line. So for the tangent line, you need a point and a slope. Point we're given is 0, 1. Slope is a derivative at the x value, which is x equals 0. So think of it as y prime at x equals 0. So you need to take the derivative of y. So that would just be 1 minus sine of x. If I plug in x equals 0 now, I get 1 minus sine of 0. Sine of 0 is 0, so that's just going to be 1. So 0, 1 is just a y-intercept. Okay, so we can write this as slope-intercept form, since we're given the y-intercept. So the tangent line is just the slope plus the y-intercept. And the answer is B. Next one, we're given y equals 2 times cosine x over 2. And we want to find the second derivative. Well, first you need to take the first derivative. So we're going to have 2. Now the derivative of cosine is negative sine. It's negative sine. Keep the inside the same. And then take the derivative of x over 2, which is 1/2. So I can cancel out the 2's here and rewrite it as negative sine x over 2. I'm going to take a derivative again because I want to find the second derivative. So the derivative of sine is cosine, but I have a negative in front, so it's negative cosine. Keep the inside the same. And then you need to multiply by the derivative of x over 2, which is 1/2. So I'm just going to put the 1/2 in front. And so the second derivative is negative 1/2 cosine x over 2, which is E. Now for 5, we're given y equals sine of x times cosine of x at x equals pi over 3, and we want to find the derivative. This one we could be very clever and say that I can rewrite this as sine 2x over 2. And this is just a trig fact, so I'm using a double angle here. Sine 2x is 2 sine x cosine x. So if I divide by 2, sine 2x over 2 will just be sine x times cosine x. And this makes me avoid using the product rule. So yeah, this hopefully is much quicker. Okay, so I'm just going to take the derivative now of sine 2x over 2. Well, I can keep the 2 on the bottom. That's fine. And the derivative of sine is cosine. Keep the inside the same. And then take the derivative of 2x, which is 2. Put that in front. The 2's are going to cancel, and I'm going to be left with cosine 2x. Next, I want to plug in pi over 3 for x. So we want to find cosine of 2 pi over 3. This is in the second quadrant, and it'll be negative 1/2. So the answer is A. Now we're left with 2 more questions. So we want to find the derivative of cosine squared x cubed. So let me just write this again. Cosine squared x cubed. It may help if we write it as cosine x cubed, and then the outside will be square. So this we have to use the chain rule. The outside function is 2. So take the derivative of that, means bring it down. Keep the inside the same. Now you want to subtract 1 in the exponent. 2 minus 1 is 1, so I won't do anything. And then take the derivative of cosine x cubed. For the derivative of cosine x cubed, you have to use a chain rule again. So you first start off with the derivative of cosine, which is negative sine. Keep the inside the same. And then take the derivative of x cubed, which will be 3x squared. So I can simplify this. Well, I can use the double angle formula here if I want. I have 2 sine cubed times cosine, sine x cubed times cosine x cubed, which I can just write it as I can write it as sine 2x cubed, and then multiply that by 3x squared. So this is like a nice simplified answer for the derivative. Okay. Now for the last one, we have y equals x squared times sine 2x. So let me just write that out. This one we have to use the product rule. First take the derivative of x squared, which is 2x. Multiply that by sine 2x. Plus now we're going to take the derivative of sine 2x. We need to use the chain rule. Take the derivative of sine first, which is cosine. Keep the inside the same. Then you want to multiply by the derivative of the inside, which is 2. And then we need to multiply that by 2x. So that would just be, well, if you want, you can factor out the 2x. So you have 2x and then sine 2x plus 2 cosine 2x. And this is perfectly fine.